This is the story of the incredible shrinking server in 4 minutes. How, despite the need for faster CPUs, more RAM, and bigger hard drives in physical machines, the footprint of software just keeps getting smaller. From bare metal to functions, each paradigm has its benefits and drawbacks. We touched on this in a recent blog. So what's your favorite flavor? Everyone knows what a computer looks like, from the outside at least. On the inside, there's a CPU, the brain, RAM, memory, HDs or SSDs, storage, and a host of other electric components. Your operating system, Mac, Linux, and Windows, communicates with that hardware. Software that runs on your computer, collections of ones and zeros called binaries, talks to the operating system, and through it to the hardware, if the OS permits it. But not all code is written to binaries. At the other end of the spectrum lie interpreted languages like Python, Node, PHP, and more. They actually execute through a layer called a runtime that handles the communication with the operating system. Between those two models, there's something called bytecode, which are also binaries, but a runtime is still required. Java does this for a combination of speed and portability. Both interpreted languages and compiled binaries often leverage shared resources called libraries to reduce the need to write something that someone else has already written, like how to talk to a database. Basically, developers don't like to reinvent the wheel, and they shouldn't. Ever been in one of those awkward situations where somebody overshares what they did last night? It happens on computers too, and there's a fix. Virtualization is the idea of running a computer inside a computer, allowing you to slice it into pieces, like cake or pizza. Virtualization is pretty tasty too, as each slice shares the same box but is completely independent. And you can never overshare pizza. VMs introduced a new layer called a hypervisor. It replaces the bare metal operating system in the task of interfacing with hardware. Each VM can have its own code, libraries, and runtime. Additionally, they can, and actually need to, have their own operating system. VMs can pass through to real hardware for things like CPUs, storage, and other devices on the system bus. This allows for something called oversubscription, where two VMs might share a single CPU. And we know that studies have shown that many companies barely use half their compute capacity these days, so why not? What they can't safely share is RAM. I think you can probably piece together the security nightmare that could generate. VMs didn't fix the library problem, they just changed it. Kind of for the worse, to be honest, at least for libraries. To the software within them, VMs reduced the size of the host on which they ran, but the library requirement still exists. And with VMs, there's a real possibility of multiple copies of that library on multiple VMs on the same physical machine. Containers take a different approach. They share the operating system but package their own runtimes and libraries. If you need it, it has to be on the container. Like a hypervisor, the operating system generally consumes very few resources, and the name is remarkably appropriate considering how containers work. Another upside of containers is portability. Assuming the same architecture, if I generate a container on my laptop, I can run it on a server in the cloud. However, they do say that nothing in life is free, neither beer nor improvements offered by containers. Like code that has to be compiled before running, container images have to be packaged with all their code and even the runtime before they can run. They increase portability, but slow down deployments. What's that you say? Smaller? Okay. Functions can literally just be code as they get their runtime from the host machine. I know what you're going to say. We just virtuous cycled ourselves back to the start. And you're right. Ish. The difference here is that you have all the isolation containers offered. And with a hyper-optimized operating system, functions launch and terminate faster than containers, and often execute in seconds, not the long-lived minutes, hours, days of containers or virtual machines. Having trouble choosing, or want to use a runtime not offered by the host machine? You can run a container within a function. But that's a story for another day. From bare to barely, servers to serverless, each paradigm has packed more work onto less resources. In that time, Dev has had an on and off relationship with Ops. FinOps was born and is gradually shifting left. The servers kept shrinking and your options kept growing. Yikes, that was a lot. I'm thirsty. Oh, look, here's something.